Hey guys, welcome to a new video. So in this video we'll be setting up the motion analysis. So far we have completed the 3D models and we will be proceeding to the multi-body dynamic simulations. Right now, before we do this, make sure that your assembly is complete, else you will not be able to proceed ahead. Okay, so first make sure that you have SolidWorks Motion installed. Alright, now this will be under the add-ins menu. However, if you don't see SolidWorks add-ins, right click on the menu ribbon and here you will see a list of options. Now these are the extra add-ons, so make sure that you click on SolidWorks add-ons and here you will be able to see SolidWorks Motion. So when you select that, the motion study will be enabled. Now in the bottom bar you can see that SolidWorks Motion Study 1 has already been created. Now Motion Study 1 was something that I already created, so let's create a new motion study. Now here you can see that it says animation. Now this is really not useful for us, right? Especially from an engineering point of view. So if you click on this, there is an option called motion analysis and this is what you want. Alright. Now what we are going to do is in the driver side we are going to add a motor. So to be specific, we are going to add a torque and that is going to rotate the driven side. So let's add a motor first. So you can see here that there is a motor icon. So let's add a rotary motor. Now we are going to select the center axis for the driver and you can see that a small arrow appears which tells us how the motor is going to spin. Now click on this arrow which basically reverses the direction, so this helps you change the direction of the motor. Alright, so now we want the driver side to move in the clockwise direction. Alright, then what you need to do is you need to provide what type of motor it is, right? It could be a servo motor or it could be a harmonic drive or it can rotate at a constant RPM, right? So if I click on this, you can see the different types. It's also possible to give an expression. So for us, we are just going to use a constant speed and I'm going to put in a RPM of 10, right? You can change it to anything you want. You can put it 200, 300 or anything that you want. As part of your challenge, you will be varying it. Similarly, you can provide distance and you can type in the degrees by which you want the driver should move. And you can also provide a time for it, right? So you're kind of providing the radial velocity. The nice thing is after 1000 degrees, the driver wheel is going to stop. Okay. Similarly, there is a start time parameter. So this can be used to basically introduce a small delay, right? If you don't want the motor to start right away, you can provide a delay. For example, if I put in 10 seconds, the motor is going to start after 10 seconds and it is going to go up to 50 seconds. So in our case, we are going to go to constant speed and we are going to type in a RPM of 5. And then let's click on OK. And that basically sets up our motor. Now, what we need to do is we need to establish the contact between the driver and driven component, and only then would there be a force transmission. So let's click on contacts, and what we're going to do is we're going to select solid body contacts and we're going to select these two bodies and you can provide the material, right? So we are going to be using steel in both the cases and click OK. So right now we've established the torque and we have also established the contacts, right? So now what you can do is you can run this particular simulation. So first make sure that you run it for the selected time. Now you have the calculate option which runs the simulation. You can play the animation from start or you can play it from the current instance. So let's hit the calculate button and this is going to do all the calculation. The spindle is going to enter the slot and that's going to impart a force which actually moves the driven component, right? And then once it leaves the slot, the driven component comes to rest. And this process is going to repeat itself again. Now if you run the simulation longer, you will be able to simulate multiple rotations, right? So after 20 seconds, the simulation is complete. Now from the simulation, we can extract a lot of outputs, right? So let's just play this one more time to understand how the motion takes place. You can click the play button, you can use the stop button to stop it, and see it at any instant that you want, right? So this is the advantage of a simulation. You can play back things again and again. You can increase the speed. So for example, now I'm actually slowing things down. Now this option is useful if you actually have a very complex motion. Similarly, you can increase the speed to create very fine animations. Now you can also select a loop mode option or a straight playback option, right? So basically after 20 seconds, currently it stops, but if I use a loop mode, then what's going to happen is it's just going to keep on repeating the animation again and again, right? So this is useful in these type of cases where the motion is kind of repetitive. You can also make it play in reverse. This might be useful in some cases. All right, so let's stop the simulation now, and we are going to now extract some useful information from this. All right, so this is what you would call as post-processing, right? So we are going to be generating some useful graphs that can actually help us design this product. So click on results and plots, and we are going to be selecting forces, right? Now you can see that there are other options which you can use, but in our cases we are going to select force, and we are going to be looking at contact forces. There are several forces that are available, but in this case the contact force makes more sense because that would be a very important design parameter. Now we are going to be selecting the magnitude, right? The magnitude of the total force. You can look at components, but in this particular case the total magnitude makes more sense. Then you need to basically select the two components that will come in contact with each other, right? So in this case you can see that I'm selecting only a few faces, all right, and I'm going to hit OK, and you can immediately see that the contact forces appear, right? So here x-axis is time and y-axis is basically the reaction force or the contact force. So now you can move the graph to one corner and hit the play button, right? So the advantage is now you can basically see at which part of the motion the contact forces are exhibited. So this basically helps us fine tune into the component motion, maybe even reduce the speed of the animation so that you can exactly understand the dynamics of the problem. Now you can subsequently take these force values and run a structural analysis calculation with it, but that is not something that we would be focusing on. All right, so with that I would like to conclude this video. Hope you basically learned how you can actually set up a very simple multi-body dynamic simulation of a Geneva mechanism. We'll see you guys in the next video. Bye.